Hi guys, happy Wednesday and Thursday. This is Mrs. Manley checking in with you for another Integrated 1 and Advanced Honors Integrated 1 lesson. On Monday and Tuesday, we started reviewing systems of equations, which you guys learned in 8th grade. On Monday, we focused on graphing systems of equations, and I had you guys sign up for Delta Math so you could do some Delta Math practice on graphing. Today, we are going to start moving on into solving using algebra. So we're going to start with the substitution method today. I have added all the foldables into Kidem. If you have a printer, you're welcome to print them out, fill them out along with me, and glue them in your interactive notebook. If you don't have access to a printer, that's fine. Just, create your own foldable or keep your own notes doing the same things that we're doing in the foldable. So let's go ahead and begin. So we're just going to jump in with the first example. So the substitution method. If you think about the word substitution, substitution means replacement. Okay, when a substitute teacher comes in, they're here to replace a teacher. If you go to a restaurant and you substitute something, a different kind of cheese on your hamburger, or you substitute hot peppers, you're replacing. Okay, so when we do the substitution method with equations, we're going to replace something in one of the equations. So, in our first example, y equals 3x minus 5 and 8x plus y equals negative 16. Before we can substitute, we need to get one of the variables by itself. In this case, that's already done. Y is by itself. So, the way I've always taught this, even when I taught it in 8th grade, is I would tell my students to box or highlight what y is equal to, and in the second equation, put a box around y. What this is telling me is I'm going to literally take what y is equal to, 3x minus 5, and I'm going to replace y in the second equation. So I'm going to rewrite it, 8x plus, and when I get to that box, it's no longer y, it's 3x minus 5, and then equals negative 16. From here, I'm just going to solve it. So 8x and 3x combine to give me 11x. Bring down my minus 5 equals negative 16. I need to get 11x by itself, so I'm going to add 5 to both sides. Negative 5 and positive 5 make 0. Sorry guys, I had to pause for a moment to answer my phone. Alright, so negative 5 and positive 5 make 0. So I can bring down 11x equals, and then I have negative 16 plus 5. Integer rules state if the signs are different, negative 16 and positive 5, I'm going to subtract. 16 minus 5 is 11. I'm going to keep the sign of the number with the larger absolute value. 16 is larger than 5. So it's negative 11. Then I'll do my last step, dividing by what's with x. So I cross out 11 over 11 because 11 divided by 11 is 1, but we don't write 1x, we just write x. And negative 11 divided by positive 11 makes negative 1. We are only halfway finished at this point. If you notice, we have an x and a y, so we still need to solve for that y. So I need to take this x and substitute it in now. Since I'm solving for y, it would make the most sense to plug it in the one that's set up for y equals. However, you can choose to plug it into either equation. So I'm going to have y equals 3 times x, which is negative 1, minus 5. Y equals 3 times negative 1 is negative 3, minus 5. Negative 3, negative 5, same sign, so I'm going to add and keep the sign. So I get y is equal to negative 8. And I'm going to write this as a coordinate pair. Okay, my solution is a coordinate pair. Why is that? Because if we were to graph y equals 3x minus 5 and 8x plus y equals negative 16, negative 1, negative 8 is where the two lines would intersect. Okay, let's move on to example 2. So example 2, we're still doing the same thing, the substitution method. So the first thing we want to do is see if we have a variable that's by itself. And we definitely do. We have y equals negative 3x plus 17. So I know this is my y. And I'm going to replace y with it. I'm going to take this and I'm going to put it here. This one you have to be careful on because we're dealing with 4x minus y. Okay, minus y. So when we rewrite this, we're going to say 4x minus, and then I need to put in parentheses because a negative sign is going to change the signs of whatever I'm dealing with. So then I'll put in negative 3x plus 17 equals 18. A negative in front of parentheses means negative 1. So if it helps you to put it there, go ahead and put it there. So again, we're just going to start solving now. So I don't have anything to do with 4x yet, so it comes down. Negative 1 times negative 3 makes positive 3x. Negative 1 times positive 17 makes negative 17 equals 18. Combine those like terms. A 4x and a 3x make a 7x. Bring down minus 17 equals 18. Now I need to get x alone. So I'm going to add 17 on both sides. So I have 7x equals 18 and 17 are going to give me 35. And last step is always divide. So x equals 35 divided by 7 is 5. And then again, we're only halfway finished. Now we need to go through and plug 5 into the top equation. Sorry, you can plug it into either equation, but I'm solving for y. So why not use y equals? So we get y equals negative 3x, which is 5, plus 17. Negative 3 times 5 is negative 15. And negative 15 plus 17, different signs, how I'll subtract. 17 minus 5 is 2. Keep the sign of the bigger number, so it's positive 2. So then I write it as an ordered pair, 5, comma, 2. You can self-check on systems of equations. So especially if you have a calculator to help you. But if you wanted to know if you're correct, you can take this 5, 2, and you can plug it back in. So let me show you. It does take a little bit of extra time, but if you want to know for sure that you're correct, this is the way that you can do it. Because systems of equations are what you can call self-checking. Let me just erase. Okay. Okay, so this is my x value and this is my y value, correct? So I can say, instead of y, 2 equals negative 3 times x plus 17. 2 equals negative 15 plus 17. Negative 15 plus 17 is 2. 2 does equal 2, so I know it works in the first one. Then I can try the second equation. 4x minus y equals 18. 20 minus 2 equals 18. 20 minus 2 is 18. 18 equals 18. So I know that this is my correct answer. Okay, so again, if you want to self-check to know you're correct, just plug back in. If you're using a calculator, if you have one of the TI-84 calculators, make sure you use parentheses when you're plugging your numbers in, like the 5, just like I wrote it. Same thing if you're using the free Desmos calculator. All right, on to example 3. Example 3. Now, notice in example 3 that we do not currently have what y is equal to or what x is equal to. But hopefully you see that x plus y equals 4 would be really simple to change. So I could take x plus y equals 4, and if I want to solve for y first, I would just subtract x on both sides and get y is equal to 4 minus x. Or I could subtract y on both sides and have x equals 4 minus y. So it depends on what you want to do. If you do it the first way like this, you're going to plug in for y. If you do it like this, you're going to plug in for x. Okay? Whichever way you choose to do it, I want you to go ahead and pause your screen and try to work number 3 on your own, and then unpause to see how you did. So on mine, I'm going to choose to use y equals 4 minus x and plug it in for y. So I'm using this equation and this equation. Okay, so I'm going to have 2x plus 2y equals 7. 2x plus 2 times 4 is 8. And then 2 times negative x is minus 2x equals 7. Combine like terms. 2x minus 2x is 0. So all I have left is 8 equals 7. Is that true? Can 8 equal 7? No, it cannot. So for this one, we write no solution. Remember that on a graph, no solution would make parallel lines. All right. Example 4. Solve the system of equations. So both of these are y equals on this one. It doesn't matter how you think about it, okay? You can say, I'm going to take negative 4x plus 2, and I'm going to put it in for y. Or you can say, I'm going to take 6x minus 8, and I'm going to put it in for y. Either way that you do it, okay, either way that you do it, what you're really doing is you're setting these two expressions, negative 4x plus 2 and 6x minus 8, equal to one another, either way you look at it. Okay, so go ahead and pause your screen, finish this one out to solve for x, plug back in to solve for y, and then unpause to see how you did. All right, here we go. So I'm going to add 4x on both sides. But you could have chosen to subtract 6x. You can move either one. So I get 2 equals 6x and 4x makes 10x minus 8. Now I need to get x by itself. So I'm going to add 8 to both sides. So now 10 equals 10x. Divide by 10. Whoops, didn't mean to cross this one out. 10 over 10 is 1 equals x. Then plug back in. So I can plug into either one. I think I'll plug into the bottom one, just because. Y equals 6x minus 8. 6 minus 8 is negative 2. So I get 1 comma negative 2, which makes sense if you plug it in, okay? Because if I do negative 4 times 1 is negative 4, plus 2 is negative 2. And the second one, if I do 6 times 1 is 6, minus 8 is negative 2. And that's where we're going to stop for today. I know it was a quick lesson. This video is going to be 15 minutes or less. Please make sure you're doing your math minutes every week and turning them in on your last class day of the week. So for the even classes, 4th, 6th, and 8th, your last day this week is Friday. For the odd classes this week, your last day is Thursday. Okay, so make sure you turn them in by those days so they're not late. Same with LHS Masteries. Even always gets it on Monday, it's due on Wednesday. Odd always gets it on Tuesday, it's due on Thursday. It's the exact same way for the in-person students. Okay, I treat you guys fairly, exactly the same. What I'm going to have you guys do for, oh, and I'm sorry, please, please, please make sure you're doing your attendance forms. I hate marking some of you guys absent every week because I know you're submitting work, but if you don't do the attendance form, I have to mark you absent. Okay? All right, that's out of the way. All right, next up for your assignment today, because obviously 15 minutes is not long enough when it should be a 90-minute class. So what you're going to do for the rest of the day is you're going to get on your Delta Math. Please make sure you are doing Delta Math because I can see your progress and I can see if you have not started it yet. Okay, once we get to the end of this unit on systems of equations, every Delta Math assignment should be completed. And if every single one is completed with 5 questions correct, you'll get a 100 for it. So again, you only have to do 5 correct per assignment. 5 correct per assignment. So on Monday, Tuesday, you were supposed to do the graphing assignments. So today I want you to work on the substitution assignments. I think there are 2 of them. Substitution level 1, which probably means you've already got one set up to plug in, and then substitution level 2, where you may have to change one of your equations to plug in. At our next lesson, we'll move on to elimination method, and I'll give you guys a chance to practice that. Okay? Have a great day. If you need anything at all, reach out to me via email. If you would like to attend a Zoom just to discuss something with me, we can do that. Or if you would like to Zoom in to watch what's going on in class, that's fine too. You guys are in a little bit different places, but you know, it wouldn't hurt to help as a little bit of a review. Have a great rest of the day.